Let's look at the second example of solving rational inequalities, meaning we have an inequality, in this case less than, and we have fractions with variables in the denominator. Example 2 is 5 over x minus 4 is less than 1 over x plus 4. So we want to know what values could x be in order to make this inequality true. Let's take a look. Step 1, move everything to one side just like we did with example 1. So we're going to subtract this entire fraction and move it over. And again, I'll show that for the students who like to see it. I appreciate that, and as long as it helps you, I'll go ahead and show it. So we're subtracting that from both sides to get 0 over here. So now we have 5 over x minus 4 minus 1 over x plus 4 is less than 0. Notice these are not common denominators, so we're going to have to do the little switcheroo where we multiply the left fraction by x plus 4 and we will multiply the right fraction by x minus 4. Step 2, combine expressions, which is exactly what I was just talking about. There's your least common denominator, x minus 4, x plus 4. Notice the denominators will be the same now, x plus 4, x minus 4. And then the numerator will become 5 times x plus 4 minus x minus 4. Notice how I left that in parentheses because we're going to have to distribute that minus into both of these terms. Step 3 is to simplify. So we're going to have 5x plus 20 here minus x plus 4 because it's a double negative. And there you go. And then we're going to combine 5x minus x, and we can combine 20 plus 4, so that's going to become what? 4x plus 24. I'm going to FOIL the bottom as well. Notice this is a difference of squares factored out. So what this will become is x squared minus 16. So we got 4x plus 24 on the top, and we're going to have x squared minus 16 on the bottom. Alright, folks, so that, I forgot my inequality sign. Remember, this is all less than 0, so let's be clear about that. So now we're going to find that kind of, not our test value, but kind of our marker value in the number line. So for step 4, we're going to set the numerator equal to 0 and solve for the variable. So we're going to set 4x plus 24 equal to 0 and subtract 24 from both sides, divide by 4. X is equal to negative 2. Again, that's just a marker value. That's not our solution, obviously, because this is an inequality. Step 5, set the denominator equal to 0 and solve for the variable. So we're going to set x squared minus 16 equal to 0. It's kind of funny how we FOILed that out. Now we could have just left it factored and solved. Anyway, that's beside the point. Although that would have saved you time, right? Because we had x plus 4, x minus 4. That would have told us that x is 4 and x is negative 4. Anyways, you can add 16 and take the square root. You're going to get the same answer. So here's 2 more marker values. So we have 3 marker values on the number line. X equals negative 6, x equals 4, x equals negative 4. All of these will be wholes. Now, here's why. Not only do we have a less than sign here, not less than or equal to, so that's going to tell us that this top is a whole. The bottom's going to be a whole no matter what because it can't be equal to 0 on the bottom. So we're going to have a whole at negative 6, negative 4, and positive 4. Now for step 7, let's choose our test values. What's less than negative 6? We'll pick negative 7. What's in between negative 6 and negative 4? We'll pick negative 5. What's between negative 4 and 4? We'll pick 0. And look, folks, there's a 4th test value to the right of 4, and it is 5. We're going to plug all those into the original inequality. Now remember, the original inequality looks like this, so we're going to plug those 4 values in for x. I'm going to plug in negative 7, negative 5, 0, and 5. And we're going to see which ones work. So when we plug in negative 7, we get 5 over negative 11. Is that less than negative 1/3? Well, looking at it, it's kind of hard to tell, right? You can tell that 5/11 is closer to 1/2. So that would mean negative 1/2 is less than negative 1/3. You can also find a common denominator. Then you will see that negative 15 over 33 is indeed less than negative 11 over 33. So what that means is when we plug in negative 7, it will work, and we will shade that part of the number line. When we plug in negative 5, we get 5 over negative 9. Is that less than negative 1? No, right? Because negative 5/9 is closer to 0, so it's going to be bigger. So when we plug in negative 5, that part of the number line will not be shaded. Plug in 0, we get 5 over negative 4. Is that less than 1/4? Well, yes, because it's negative and 1/4 is positive. So what that means, that part of the number line at 0 will be shaded. And finally, when we plug in 5, we get, is 5 less than 1/9? And the answer is no. So only at 0 and negative 7 will they be shaded. So what that means is this part of the number line where we plugged in 0 will be shaded, and this part of the number line where we plugged in negative 7 will be shaded. It's going to look like this. Our answer again is going to be or, right? It can't be both, right? X can't be negative 8 and 0. But what we can say is x is less than negative 6, or x is between negative 4 and 4, not including, again, we have the holes there. That's it for this example. If you have any other questions about it, let me know.